and welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it, pause the video, come back, and we'll do it here. An object has a mass of 200 grams and a volume of 10 cubic centimeters. What is the density in grams per cubic centimeters in centimeter of the object? So they're telling you what the density is defined as. It's defined as number of grams per cubic centimeter. So to get the density, which is very often shown as said like this one, sigma, or usually that's sigma. Density is 200 grams over 10 cubic centimeters. That's it. That's the answer. And then you just simplify. Is that right?
Yeah.
Grams per cubic centimeter. It's shocking. This is a question 31 of a calculator section of the October 23 test.
So what's the answer?
Oh, the answer is you divide this. So the answer would be 20 grams per, or gram. I'm not sure if it's grams or gram. Cubic centimeter. So the answer is 20. That's what you would bubble in on the test.
Yeah.
Wow, there's really not much to this question. The unit analysis, of course, helps you. You don't necessarily have to even be... I guess you don't necessarily have to know what the definition of density is, but they tell you the definition of density. And this is strictly a unit problem. And you don't even have to convert any units. Like, they're not asking you for kilograms per cubic centimeter or grams per cubic millimeter or grams per cubic meter. So it looks like just a surprisingly easy question. What do you think? Yeah, I mean, what are we going to say? So,
easy question.
So I guess we'll go through the 4 or 5 questions we have here. Okay, let's start with the question we came up with yesterday. Is there a special pattern in this question that you would take advantage of? Not really. Not really. I mean, the pattern is the whole question itself is grams per cubic centimeter. If that's a pattern, that's actually the essence of the question. What is the main idea? When the test takers, the committee came up with the question or decided this question, what were they deciding to test? Maybe just understanding how to calculate a physical characteristic of that requires units, a physical characteristic of an object, given the units that physical characteristic has to have. It's a bit of understanding units here, a bit of just knowing that you could just let the units do the thinking and let the units do the walking, as we used to say with the phone books, the yellow pages. So, I mean, yeah,
I think it's a test of one of many elements in general education about science.
Yeah. Yep. Okay. Calculator. I mean, hopefully it doesn't. You don't need a calculator to do 200 over 100, but if you do, the calculator is available, and you can divide 200 over 100 with a calculator.
Yeah.
And starting with the guess, that doesn't apply. This is a free response question. And does this question differ from a question you can get on at school? Not really. Not really. You can easily get this as a question in school. Normally, you would get a question. They would say, this is the grams per 10 cubic centimeters. And they would say, what is the density in grams per cubic millimeter?
I think this is the kind of question that would be, one of the first homework questions after a lesson about what is density.
Yeah, right. That's right. Yeah. Okay, so yesterday we had technical problems. Today's Friday. Yesterday was Thursday. We had technical problems with our Throwback Thursday questions. So today, Friday, we're going to do the Throwback Thursday question. So, there's still a few technical difficulties here, but I think we will deal with them. What we're going to need to do is we are going to need to stop the share and go to another application. So we stop the share. We go like that. This is our Throwback Thursday question, which everyone sees except Seth. Now Seth sees it. Seth, do you see the Throwback Thursday question?
Yes.
Good. Now I just have to bring in annotation, and we are ready to go to Throwback Thursday. This question comes from a review book, an SAT review book from over 20 years ago. So this question here does not even look anything visually like anything you'd be asked on the post-2016 SAT. So let's try it. In a plane, two regions, S and T, are called unlinked if S has no points in common with T, and any line segment that can be drawn with both endpoints in S has no points in common with any line segment that could be drawn with both endpoints in T. Seth, this is up your alley, because this is like combinatorics and mapping. Seth is a PhD in math.
It's geometry.
Oh, it's geometry. Okay. Which of the following shows a pair of regions that are unlinked? I don't know about you, but I have to read this question a few times. So, wait. So we can knock out E, right? Because E has points in common. So E is gone. Now,
where's the point in common?
There are 2 points in common.
No.
What?
That's the whole region.
What?
The whole circle is
right. Okay. Yeah. Sorry.
Yeah.
Yeah.
So there are many points in common.
Yeah, there are an infinite number of points in common. Sorry.
And so, but all it takes is one.
Right.
So I will mark 1 point that they have in common.
Fine. Okay, good. Okay, so let's get E out of there. E's off the table.
And now, similarly, this one has 1 point in common.
Oh, you're right.
Wait. Is S? No. S looks like S is this region. Right?
Yeah.
Is it that? It's ambiguous.
We don't know.
And T is this region.
Well, T is definitely the small region.
Yeah, okay.
We don't know what S is.
So these don't have any points in common.
Yeah, but I hope S isn't the whole thing. Well, we don't know.
If S were the whole thing, then they would have points in common.
Right. So we don't know.
But either way, D it doesn't qualify.
Okay, now what does this mean? Any line segment that can be drawn with both endpoints in S and has no points in common with any line segment that can be drawn with both. Seth, I'm just going to be spending my time. Do you understand this?
Yes.
Okay, good. Then why don't you go for it?
So I would do it by, I would look at it by elimination.
Okay.
So I look at C. I'm going to do is draw with straight lines. Here is a line segment with both endpoints in S.
Oh, I see what it means now. Okay.
And here is a line segment with both endpoints in T. And they have a point in common.
Wait, any line segment that can be drawn with both endpoints in S has no points in common with any line segment that can be drawn. Okay, got it.
Similarly, here is a line segment, both of whose points are in T. And here is a line segment, both of whose points are in S. And
right.
They have a point
in common, right. Yeah.
Now look at this one. This is a little bit S. So here is a line that has both endpoints in S. And Here's a line segment that has both endpoints in T.
Got it.
So this one's no good. This one's ruled out, and therefore, then using the principle of SAT questions, exactly one choice is correct. What's left is A.
That's right. Yes. So yeah.
Now,
I see.
However, that's not good enough for a mathematician.
Okay.
Because a mathematician wants to treat this by proving by proving that there's no way you could have a line segment both endpoints are in S and a line segment both endpoints in T where they meet. Right? And the way you could prove this is by observing that there's a separating line that separates S and T.
Okay.
And any line segment that's both of endpoints are in S, every line segment is all above the green line.
Yep.
And any line segment both of whose points are in T is below the green line.
Yep.
And there's no way, and if so any common point of the two line segments must be either on the green line or above the green line or below the green line. But there is no point in the lines in any of these line segments that's on the green line. And there's no point in common. There's the region above the long green line and below the green line have no points in common.
Yep.
So that constitutes a proof.
Okay.
That no matter.
Yeah. And
so that's all. That's what this problem is about.
Right. Okay. Yeah. And so, Seth, when you drew that line, did you mean to have it touch S or not really touch S? No. Okay. So it's just an infinitely small amount right below S. Okay. It's not actually. So Seth should have drawn it like this. Right.
Can I move it?
Go ahead. Go ahead. Sure. Be my guest. If you can, but let's just say it's not touch. It's not on that line of S. It's slightly below, even though it's not drawn to scale. We'll cover ourselves and say not drawn to scale.
Yeah.
Okay. But anyway, that's a detail. That's a detail that we just made clear. It's not a detail, but we
now. Thing is, this question, like many questions in this corpus, uses an idea that is one of many important ideas in math that people are taught when they learn math.
Okay.
So there's a name for this for the concept that they're talking about here, and there are many properties, simple properties, and some very subtle properties of the concept. And the concept is called, well, I have to give a name for it. The name of the concept is called convex closure.
Okay.
The convex closure of a region is a set of all points that are on line segments, both of whose endpoints are in the given region.
Okay.
That's called the convex closure. And that this property, this question could be rephrased as saying that the complex closure of S and the complex closure of T have no points in common.
Got it. Oh, okay.
Now, the thing is, what's remarkable about S and T in part A is both of them are convex sets, which means that they equal their own convex closure,
Okay.
and they are disjoint. And that guarantees that there's no that this property is true. For all the others, we have the case of E where the two sets are not disjoint, which is ruled out, or the case where one of the sets is not convex. Therefore, and there's a line segment that sort of starts in the set, goes out of the set, and then comes back into the set.
Right.
So that line segment is included in the convex closure, and that line segment happens to intersect the other set.
Yeah. So the
And
one
then
the one that goes in is a concave shape, right?
Yeah.
Yeah.
So S, the one that goes in is a non-convex set.
Yeah. Right.
Its convex closure, we'll do it in red. Its convex closure which I'll do in red. Its convex closure is this region.
Hmm.
And it's filled in. This whole region.
So you learn about this.
Closure.
You probably learn about this in a college geometry class.
Yeah.
Yeah. Okay. Fine. Okay.
Yeah. So this red region is the convex closure of S.
Right.
And it intersects T.
Yeah. Right. So you can see back, been 20 years ago, they were putting questions on that you would really not be exposed to at all in school, but you had to have some intelligence.
Yeah.
Outside school.
Yeah.
And you have
So it's a matter of logic. Notice when I explained it, I said nothing. I did not rely upon the concept of convex closure.
Of course not.
But
obviously.
What I did do was make use of my knowledge of it.
Yes.
And then so I unwound the meaning of the concept and translated it back into what it means in terms of line segments and points.
Yeah. And we don't go into massive analysis on the older questions as to how to approach them. Well, of course, you learn that from us, and we hopefully discuss that. But the emphasis here is just to make a contrast between the older SAT questions and the newer one.
Yeah.
This is a pretty old question. It has a very old feel to it. Okay, so I guess that's it, right? So we're done. Okay. Have a great weekend, everyone. I'm Joel. I have a PhD in math. My brother Seth is a PhD in math. No. Today it's been a long week. Oh, no,
you got it mixed up?
It's been a long week. I have a PhD in mechanical engineering. That's why I couldn't do this problem as easily as Seth. Seth is a PhD in math. And we're brothers. We're here to hopefully give approaches and give advice and suggestions on how to approach SAT math questions. And we try to meet every day. In terms of practicing, go to Blue Book, go to the College Board and take as many digital practice tests as you can. Learn from the mistakes you make. Look whatever topics you're weak on. Go to the Khan Academy website because they have lists. They have 30, 40 questions, 20, 30, 40 questions on each topic. Study those, learn from your mistakes, and just keep practicing. I guess that's about it. Please give comments on our videos. We take our comments very seriously. And if you have any SAT math questions you'd like us to do online, like right here, please email them to us at satmathquestionoftheday@gmail.com. Guess that's about it, right?
Yeah.
Okay, great. Okay, everyone. Have a great day. Have a great weekend. And we hope to see you Monday.